Working on tonight?
Some a lot of word problems. Yeah. Can you me say one or?
Yeah, why don't you go ahead and read it?
Okay. It says you drop a ball from a height of 98 feet. At the same time, your friend throws the ball upwards. The polynomials represent the heights in feet of the balls after t seconds. Write a polynomial that represents the distance between your ball and your friend's ball after t seconds. And I can tell you those numbers. The top one, which is being thrown down, is negative 16t squared plus 98.
Okay.
And then the ball being thrown up is negative 16t squared plus 46t plus 6.
Okay, let's talk about this first equation.
Okay.
That represents the height of that ball at any time. Notice that when that ball is dropped, t is 0. So it's at 98 feet. And that is the height of that ball, 98 feet. After 1 second, it drops 16 feet. So the height's only going to be 82 feet.
Okay.
You see the way that works?
Yeah.
This 16t squared comes from the force of gravity and the acceleration due to gravity.
Okay.
Well, the ball that's being thrown up also has gravity acting on it, so you still have that minus 16t squared there. But additionally, it's being thrown upwards with a speed of 46. That's why you have this middle term here. And it starts from a height of 6 foot. It's not being thrown up from the ground. It's being thrown up from some tall guy's hand.
Okay.
Okay? So this is headed up. This is headed down. What's the question?
It says write a polynomial that represents the distance between your ball and your friend's ball after t seconds.
Okay. Well, this is height of your ball.
Mm-hmm.
It's the height of Connor's ball. The height of his friend's ball is that. What's the distance between them?
Would you just subtract the two?
It's h of c minus h of f.
So will that just be
So the real problem here is merely subtracting polynomials.
okay.
So we're going to take this polynomial and subtract this polynomial. That will give us the height of the ball at any point in time. So let's do that. What is the top polynomial minus the bottom polynomial?
Okay. Well, if you're going to subtract the two, that changes the signs on the second one, right?
Yeah. In other words, let's write it out how we want to do it here.
Okay. So
Let's start with the first one.
So,
I'll write it out like this. There's the first distance, and I'm subtracting this quantity, minus 16t squared plus 46t plus 6. I put the whole thing in parentheses because this is the height of the bottom ball. We need to subtract its height from the top height. You don't really need parentheses around that. I can put it in for clarification, but they're not needed. Okay. So now how do I subtract all of that stuff?
Well, you have to combine like terms.
Well, first of all, let's get rid of the parentheses.
Okay.
When I lose the parentheses, what's the sign on this?
That's a positive.
Okay, so I can change this to a positive as long as I change that to a positive. What happens to the sign on the middle term?
It becomes a negative.
Okay, let's change that to a negative, and the 6?
It's going to be a negative.
Okay, so now I can erase the parentheses, get rid of the double plus. Now I've got just 5 terms I need to combine like terms. How many t squareds do I have?
You have 2.
After I combine everything, how many t squareds do I have?
0.
Okay, those cancel. How many t's do I have? Let's list that next.
1t.
And that is minus 46t. Takes care of that term. How many total numbers do I have?
2, which is going to subtract to 92.
Plus 92. There's your answer.
Okay.
Notice that when t is 0, this says that they are 92 feet apart. That makes sense because the ball started at 6 feet off the ground and the upper ball started at 98 feet off the ground. So this answer fits for when t is 0. When t is 1, it's still going to be 46 feet difference because the ball on the bottom hasn't reached the ball falling yet. But notice that when t is 2, the difference between them is 0. So at t equal 2 seconds, the balls hit. Collide. Which I don't know, is that the second part of this question, or is this strictly a how to add or subtract polynomial question?
Just how to add or subtract.
Okay, I thought so. This actually is a pretty good physics problem. It also can be a pre-calc problem. This problem is useful in any number of areas of math. I thought for you it primarily would probably just be a polynomial subtraction problem.
Right. Okay. The next one is the cost in dollars of making B bracelets is represented by 4 plus 5B. The cost in dollars of making B necklaces is represented by 8B plus 6. Write a polynomial that represents how much more it costs to make B necklaces than B bracelets.
So what am I going to do here?
Okay, so you're going to subtract. You have to find a difference.
Okay. Subtract what from what?
The 4 plus 56. And,
actually, that's 4 plus 5b.
Oh, B. My bad. I'm sorry.
All right. It's the way I wrote it. Looks like a 6.
Okay. So yeah, we're going to subtract the 8b plus 6 from the 4 plus 5.
Or we're going to do it the other way around.
A little bit around. My bad. I'm sorry.
Because they want how much more it costs to do B necklaces than B bracelets, right? So you have to subtract, you have to do C of B necklaces minus C of B bracelets. And that would give you the how much more expensive it is to produce the B necklaces. So, all I do is do this minus that. What do you get?
Okay. Let's see, it's going to be 4 minus 6, that's going to be a 2. And then 5 is going to be a 3b. So 3b plus 2?
The other way you can look at that is, since everything's positive, there's no negative signs to worry about, let's just subtract the b's and I get 3b. Let's just subtract the numbers. And there you go.
Okay.
Okay?
Okay. The next one says the number of individual memberships at a fitness center in M months is represented by 142 plus 12M. The number of family memberships at the fitness center in M months is represented by 52 plus 6M. Write a polynomial that represents the total number of memberships at the fitness center.
I'm not sure I got this down right. I think this is just adding the two together, right?
Yes, I think so. Yeah, the total number of memberships at the fitness center.
The first one was the number of fitness is equal to, read the problem again for me, just so I make sure we don't mess it up.
Yeah, sure, sorry. The number of individual memberships at a fitness center in M months is represented by 142 plus 12M.
Okay.
The number of family memberships at the fitness center in M months is represented by 52 plus 6M. Write a polynomial that represents the total number of memberships at the fitness center.
Okay. Seems pretty clear we need to add them.
Okay.
Right? In other words, there's no overlap. You're either on an individual membership or you're on a family membership. So the total number of memberships is going to be the individual memberships plus the family memberships. The individual memberships is that function. Family memberships is that function. Add the two functions together, you got the total memberships.
Okay.
What do you get?
I'm going to have to use a calculator, so okay. Okay, it's going to be 194.
Okay.
Plus 18M.
Good. Okay. What else?
Okay, the next one is a hotel installs a new swimming pool and a hot tub. Write a polynomial in standard form that represents the area in the patio. And you have a picture for this one. I'll try to verbalize it.
There's the swimming
it's a
pool.
square. Okay.
What shape is the hot tub?
It's a square up in the right-hand corner, and it's right. All right,
here, let me draw the swimming pool down here. Like this?
Okay, yeah. Yep, and it's going to be on one, and then you're going to, at the top left-hand corner of the pool, you're going to draw up, and then make a right on where, and go to where the hot tub is.
So, this is the...
It's like a giant rectangle around the entire thing.
Just a full rectangle?
Yep, around the entire thing.
Okay.
Okay, so the top of the pool, it's 6x minus 14 feet.
Okay.
On the side of that, it's going to be 2x feet.
Okay, and the hot tub?
The hot tub is x feet for all four corners.
Okay. And the rectangle?
Okay, the top is going to be 8x minus 10 feet. And then on the side there, from the point of where the, from the middle of the rectangle up is 2x feet. So kind of like where the borderline of the pool is. Where the top of the pool is to the top of the rectangle, that's 2x feet.
Right there?
Yep. And then that's it.
That doesn't give us the width of the outside rectangle.
No.
Well, missing in the
sorry. Yeah, no. The pool is 2x feet as well, so it's going to be 4x feet for the entire thing.
Okay, so this side is 4x.
The pool, in the picture, the pool meets up with the rectangle. It touches the rectangle.
Okay, I got it. I got it. The way I... So, well, that's okay. So the rectangle really goes like this?
Yes. And the same thing with the hot tub. The hot tub touches it too.
Okay.
Yeah. Sorry.
That's all right. All right. So this is a shaded area problem.
Okay.
Okay? Shaded area problems are always subtraction problems. We're not going to calculate the area of the patio. What we're going to calculate is the area of the outside rectangle minus the area of the swimming pool minus the area of the hot tub.
Okay.
What's the area of the outside rectangle?
Okay, so it's going to be 4x times 8x minus 10.
Okay. Subtract the area of the swimming pool.
Swimming pool's 2x times 6x minus 14.
And also subtract the area of the hot tub.
This is going to be x times x. So x.
X squared. Okay?
X squared.
So that answer is your answer that needs to be simplified. What's the first step to simplifying it?
Combine like terms.
Yeah, we got a bunch of parentheses here.
Oh,
Remember PEMDAS. Whenever you have a bunch of stuff to do, always do it in that order. Now, sometimes you can do the exponent first, but you want to usually get rid of your parentheses as your first step. So how do we get rid of that parentheses?
You're going to have to multiply,
Okay.
distribute.
So distribute the 4x to both of these terms. What do you get?
Okay, so 4 times 8, 16, 32.
32x squared. In other words, you have to multiply the x times the x also.
Okay, and then minus 40x.
Okay. Now, we want to work from the inside out.
Okay. So
let me leave one set of parentheses. Go ahead and distribute the 2x.
Okay, so it'll be 12x squared. And then it would be 24x. Minus 24.
28x.
Oh, 20, my bad.
And make sure that sign is minus, because all we're doing is distributing that at the moment. We're not getting rid of the second set of parentheses yet. Okay, and finally, this last term, I don't need parentheses there.
Okay.
Okay, now let's get rid of the middle set of parentheses.
Okay.
So we got 32x squared minus 40x, what?
Okay, so then you're going to distribute the 40 to the 12 and then 28.
Hold on. You're distributing the negative sign to both terms.
Oh. So then it's just going to be a negative 12 and a positive 28x.
There you go. Yeah. In other words, our only goal is to get rid of these parentheses at the moment. And when I get rid of them, that's what I have. And see, that's very, very easy to get the sign wrong if you get a little hasty with this problem. That's why it's really worthwhile to get rid of one set of parentheses at a time almost, just so you don't make a mistake. Okay, how many total x squareds do we have?
We have 2.
Actually, I have 3. There's one over here, one there, and one there.
My bad, sorry.
Combine them all?
Okay, so that's going to be, let's see, it's going to be 73 x squared.
Hold on. 32 minus 12.
Oh, sorry, I did the 40.
That's okay.
Okay, this is going to be 20, 21. No, because you're subtracting. 19x squared.
19x squared. And when I have problems like this, to make sure I catch everything, I go through and I cross it out just so I won't forget something.
Okay.
Now, how many x's? There's only 2 things left. They're both x's. How many net?
See, it's going to subtract to, or add, right, because it's 40 and then 28.
Minus
so
40 plus 28.
12?
Minus.
No, 22.
Minus 12.
Minus 12.
X.
Okay.
Okay? In other words, if you do minus 40 plus 28, that's equal to minus 12.
Okay.
And you have to bring the minus sign. You can't drop that minus sign. When I crossed out the 32x squared, I didn't cross out the minus sign. When I crossed out this 12x squared, I did cross out the minus sign. And I crossed out the minus sign for that x squared. But you got to maintain your minus signs where they're still left. Okay? So there's your answer. And do they tell you what the area is so that we can solve for x or not? They're just gonna. They just wanted the answer as a function of x.
I think we're gonna be doing that tomorrow. So.
Yeah. If they told you that that area of the patio was equal to 100,
then you would solve from there?
Yeah. In other words, I would set our function equal to 100, and then I could solve for x because that is a quadratic. And always solve all quadratics. Okay?
Awesome. Okay, the next one says the shipping container is a rectangular prism. Write a polynomial that represents the volume of the container. And, okay. Yep.
Okay.
So the width, like the first, that is x plus 1 feet. And then going backwards on the bottom,
Depth?
Yep, that is 4x minus 3 feet. And then going upwards is x plus 2 feet.
Okay. The volume is going to be what?
The volume? Okay, so it's, wouldn't you add them together then?
Multiply them. The volume is the length times the width times the height. In other words, the volume of any rectangular box, or what I call rectangular bricks, is the 3 dimensions multiplied. Just like the area of this face is 2 dimensions multiplied.
Okay.
In other words, the area of a rectangle is base times height. The area of a volume rectangle is base times height times depth.
Okay.
So let's substitute for each of those. So we have x plus 2 times x plus 1 times 4x minus 3.
Okay.
Now, I'm doubting that they're going to let you get away with that answer. They want you to multiply it out, I imagine.
Okay.
So let's do it. How do we multiply these 3 binomial terms by one another?
Can't you use ET?
Yep. But you can't do all 3 of them at the same time. You want to do 1 times 1, come up with an answer, and then multiply that by the third one.
Okay.
So let's multiply that by that for starters.
Okay, so that'd be x times x is x squared. And then, let's see, x times 1 is x plus x.
Okay.
And then it would be 2 times x, it's 2x. And then 2 plus 2.
And let's simplify that.
Okay.
What
okay,
can you
so
combine?
the x's together, the x and the 2x.
Okay, so what do we have?
3x.
So we have x squared
X squared plus
3x plus 2. Usually when you're writing polynomials, you want to write them in order. In other words, the highest degree to the left, the next to that, and then the number at the end. Okay, and we're multiplying that by 4x minus 3. Now this is probably what you haven't done a whole lot of, is multiply trinomials. This is a trinomial. There's 3 terms. by a binomial. This is where FOIL would not work, but ET does.
Okay. So I have a question. Could you, using ET, start with the factor on the right?
Yes, and in fact that might make it a little easier for you. Let's just switch these.
Okay.
Might make it a little easier for everybody, not just you.
But then you have to put it in backwards?
It could be done either way.
Okay.
It could be done either way. ET, start from the left.
Okay.
What's the first term?
So it's going to be 4x times x squared. It's going to be 4x to the power of 3.
Next term?
It's going to be 4x. That's going to be 12x squared.
Next term?
Let's see. It's going to be 4 times. That's going to be 8x.
Okay.
What's 8x?
Next term?
Okay, negative 3. That's going to be negative 3x squared.
Keep going.
Okay, it's going to be negative 9x.
Okay.
And then it's going to be, negative 3.
Negative 6.
Or negative 6.
That's all right.
My bad.
Okay. Now, I like the way you did that. You did it in a methodical pattern. You started with far left, multiplied it by all 3 terms. That's what you always want to do. Then you go to the next term and multiply that by all 3 terms. That's exactly what you did. As opposed to randomly doing it. In other words, I can multiply that by that, and then if I decide to multiply that by that, okay, now I can go back and multiply this by that, and this by this. Did I forget anything? Yes, I forgot 2 things. So when you randomly do it, it's really easy to miss one. So always be very methodical. Always do it exactly the way you did it. Start with the term on the left, multiply it by all these terms, and then just like you did it. Now let's simplify this.
Okay.
Now, when you're simplifying it, this term's always going to be the only one that has x cubed, and this term's going to be the only one that has any numbers. So the only things we have to combine is everything in the middle. Okay? Just good to know. In other words, it saves you time looking for all of the x cubed terms. Because sometimes you can have a lot of terms. If I've got a trinomial times a trinomial, I got 9 terms. But that one will always be the only one that has the highest degree, and that one will always be the only one with just a number. So I can start out immediately that way. Now how many x squareds?
Let's see. 9 x squared.
Plus 9x squared, yeah.
Minus 1x. And then minus 6.
There you go. Okay. Now, it would have been the same thing, notice, if I'd have left it the way it was kind of read to it, thus. Produces the same thing. I'm still going to take this term, multiply it by that, and then that term, multiply it by that, and then this term, multiply it by that, this term, multiply it by that, and finally the last term, multiply it by that, and the last term, multiply it by that. Add them all together, you get this exact thing. Okay? So it doesn't really matter whether we have the trinomial on the left and the binomial on the right, or vice versa. If you find it easier having the binomial, then switch them. In other words, whenever you're multiplying, A times B is always B the same as B times A.
Okay. Okay. The next one says, you design a frame that's around a rectangular photo. The width of the frame is same on every side, as shown. So it's 22 inches in In width and height, it's 20 inches. Or my bad. On the outside, there's about this is kind of hard to explain. If you draw a line underneath and on the side, that might help. Like underneath the photo and on the side, about the same length as the photo. Like
that?
Underneath, my bad, like directly underneath the same width as the photo.
Okay.
Okay, so now about an inch from each side of that, draw a vertical line.
Huh?
Like inwards, my bad, like an inch from there.
I got you.
And then that is X. So I'm sorry, it's kind of hard to verbalize.
Yeah, no, I understand perfectly. X is this inch, or is it the height of that?
No, it's the width.
Okay. What is this thing here we're drawing?
That is the measurements. The middle section is 22 inches.
This is 22 here?
Yep.
Okay.
And then on the side, it's the exact same thing, except it's 20 inches in the middle. Not 22.
Okay.
So it's like X in 2 spots.
Okay, so in the middle we have a line like this, and that distance is X from there to there, and that distance is X from there to there, and this is 20.
Yep.
So the dimensions of our picture, this thing here, are what?
Where? Sorry.
What are this picture that's inside the frame?
Huh?
What are its dimensions?
They don't tell you.
Well, we can figure it out. It looks like it's 22 plus 2x.
Okay.
Assuming this line here and this line here line up with the sides of the picture.
Oh, sorry, my bad. They line up with the edges of the frame.
Okay. So X is that distance there.
Yes.
Okay,
yes.
now we're in business.
My bad.
I almost suggested that because that's the way these are usually stated. So this distance here is X, and this distance here is X. All the way around, right?
Yeah.
And the frame is 22 by 20
yes.
for the picture?
That's what the frame is.
Oh.
The frame is 20 by 22.
Okay. The frame is the outside rectangle. The picture is the inside rectangle.
And they give you no information for the picture itself.
I got you.
Just the frame.
So the frame is 22 by 20.
Yep.
And they want the area of the picture, right?
Right.
Okay. What is the length of the picture?
Oh, sorry. They want, my bad, they want the combined area of the photo and the frame. Which would just be 20 times 20, right? Okay.
I think they may want this area or the area of the picture. I'm not sure what they're asking for or what exactly they've given us here. Because if my picture is right, then the area of the frame and the picture is just 20 times 22. So I don't think that's what they're asking for.
Okay. Because, yeah.
The area of the picture itself...
okay, I made another mistake. You're going to hate me for this. The picture is 20 and 22, not the frame.
That's all right. So that's 22 and 20.
They wrote it kind of weird. So.
Now, what is the frame dimensions?
Just X, and it's the same width.
It would be 22 plus 2X.
Oh, right.
This is x here, and this is x here.
Okay.
Okay? And so what is the height of the frame?
20 plus 2x.
Okay, so this is 20 plus 2x. So now the area of all of it is 22 plus 2x times 20 plus 2x.
Okay.
Right?
Mm-hmm.
In other words, the height times the width.
Then would you just combine?
Well,
Or
multiply those together, and you get your answer. ET-ET-em.
Okay. 22 times 20. 440. Okay.
Plus 44x plus 40x plus 4x squared.
Okay.
Rewriting that
So,
gives me 4x squared. How many x's do I have? 84x plus 440. So there is the area of both the frame and the picture. What else do they give you or ask you? Is that all they ask?
no. For part B, it says find the combined area of the photo and the frame when the width of the frame is 4 inches.
Okay, so when x is 4. Right? In other words,
right.
if this is x, that's the width of the frame. All the way around, it's x.
Sorry.
So all I'm going to do is substitute 4 into this. We've already decided that that's the combined area of the frame and the picture.
Mm-hmm.
That's the area of the outside rectangle.
Mm-hmm.
So if I want to know what that area is when x is 4, we'll just substitute 4 in for x. And now we can come up with that number. That's 64 plus 336 plus 440. What is that? That is that's 400. And that's 440, so 840 is the area of the outside rectangle. Now, it's worth noticing that when they say the combined area of the frame and the picture, that's the area of the outside rectangle. Do you see why? The frame is actually just that.
Because you have to subtract.
Well, yeah, technically the frame is the outside. If I remove the picture, I'm going to find a big hole in the frame. It won't be a solid rectangle. So when they say the area and the frame, they mean the inside rectangle plus the frame or the outside rectangle. And the outside rectangle is that wide, that high. Multiply the base times the height, and then substitute 4 for x. You got your answer.
Okay. Okay, this one says write a polynomial that represents the area of the shaded region. So the first one is a rectangle, and the width is 2x minus 9, and the height is x plus 5.
What's inside?
Nothing. They're all right angles, 90-degree angles.
So they just want the area of this rectangle?
Yeah, I believe so.
Shaded region. Usually shaded region problems means there's two shapes. In other words, let's say there's a round swimming pool.
Oh, yeah. On the other side, for number 8, it's a triangle. But I don't know.
Yeah. Probably when you're going to be working with problems like this, best thing to do before our session is to take a picture. Do you have a smartphone with a camera on it?
I do.
Just take a picture and send it to, not to my phone, but to my email address. And then I can bring it up and we can both be looking at that picture. Because some of these things are awfully hard to describe.
Yeah.
Like this one. I'm not quite sure I'm drawing the picture right. I've got a rectangle, but what's inside
it
the
looks exactly right compared to the picture.
What's that?
It looks exactly the same to the picture they have.
Okay.
I think we just have to multiply the
the area of that rectangle is 2x minus 9 times x plus 5.
Okay.
But I'm curious as to why they said shaded region. Because shaded region, there needs to be something else in there for there to be a shaded region.
Yeah, I don't know.
In other words, if I put a round swimming pool in the middle, or a hot tub, that had a radius of x, now this is all the shaded region. Okay, so let's figure out the area. Let's solve this problem here.
Okay.
Well, the shaded region problems are always subtraction problems. So to find this shaded region, I would take the area of the rectangle and subtract the area of the circle. Well, the area of the rectangle is 2x minus 9 times x plus 5. And subtracting the area of the circle, what's the area of a circle with radius x?
Is that pi times x? So
pi r squared, so it's pi x squared.
Okay.
So there is your answer. Now, you'd have to combine, multiply these two, and then combine it with this, but that would be your answer. Okay, and that's typical of shaded region. And the reason is that we don't have the geometry to figure out the shaded region. We have no way of calculating an area that looks like that.
Okay.
You know what I'm saying?
Right.
We don't know the geometry for calculating those kind of areas. But what I do know how to calculate is the area of a rectangle and the area of a circle. And I can see that the shaded area is the rectangle minus the circle. And shaded areas are almost always subtraction problems. It's always the area of the outside figure minus the area of some inside figure, leaving the shaded area.
Okay.
Okay?
That makes sense.
I'm not sure what they want on this one. But.
Okay. The next one is asking the exact same thing, except it's a triangle. And yep, except it's a right triangle. My bad.
All right.
There's one right corner, the lower. Yep. So for the left side, the height is p plus 1. And then on the bottom side, it is 2p minus 6.
They just want the area of the triangle?
Mm-hmm.
Okay. What's the area? What's the general formula for the area of a triangle?
I don't remember. Oh yeah, because don't you multiply to make like act as if it was a rectangle and
it's half. Well, think of a triangle as being half of a rectangle. Okay, and the area of a rectangle is base times height. Okay, if I draw any rectangle and I put a triangle in there, that's half, right? Right. It doesn't even matter how I put the triangle in there. If I put the triangle in there like that, it's still half. If I put the triangle in there like this, it's still half. So triangles are half of the area of a rectangle, and this is probably the most important formula in geometry. Now, you haven't had geometry yet, but Have you? I mean, have you learned the area of a triangle?
Not, I mean, a little bit, but it hasn't, like, we haven't gone into detail with
Okay,
it.
okay. Because this would be a hard question to answer if you didn't know the formula for the area of a triangle. Okay, so now let's just fill things in. What's the base?
2p minus 6.
What's the height?
P plus 1.
Now, let's multiply those. There's our area, and they just want it as a polynomial, right?
Right.
Okay. What's the first thing you want to do here?
Distribute the half.
Yeah, to this term here. You could distribute it to either of the two terms, but if I distribute it to this term, I'm going to leave nothing but whole numbers. If I distribute it to that term, I'm going to leave fractions.
Okay.
So distribute it to this term.
Okay, so would just be 2p?
What's 1/2 of 2p?
Okay. Oh, my bad. 1p. P
1/2 of 6.
minus 3.
Now I'm multiplying p minus 3 times p plus 1. Go ahead and do that.
Okay. Sorry, give me a second. So it'd be p squared, and then it'd be minus 2. Or sorry, my bad. Minus 3. Oh, I am so sorry.
Okay, there times that, and then let's follow the same methodology as before. That times that.
Okay, so p plus 1, just p.
Now this
then
times this,
minus 3p,
and finally,
and then negative 3.
okay. Now simplify the two middle terms.
Okay, so it's going to be p squared, and then it's going to be 2p minus 2p.
Minus. When you're writing a polynomial, you can't drop the sign. In other words, if it was plus, you couldn't just say 2p. You have to write plus 2p because it's being subtracted or added to the term before it. So it's not like plus signs. It's not like you can leave it blank and have people assume it's a plus sign. This plus p right here, I could not just say p. That doesn't have any meaning there. It's p squared next to a p. If I want to add that p to the first term, then I've got to put that plus sign there. And the minus sign in the second one. So there's your expression for the area of that triangle.
Okay.
And I could even say that its area as a function of p. You know how they'll use f of x instead of y?
Right.
Where if I say y is equal to x plus 1, well, I could say f of x is equal to x plus 1. And that makes sense because what this means is I have a function and the variable is x. Well, down here, I have a function and the variable is p. So I'm going to write it a of p. That's how you would say that. And I could call that y, or I just could call it a for area. But it's a little more descriptive if I call it a of p because that tells me that my area is a function of p. Not x, not r, but p. So whatever is in the parentheses here has to be the variable that's on the other side of the equation. Same as this up here. Okay?
That was my last problem. So do you have like any problems you can give me, or?
Yeah. I'll make one up here. I'll make a shaded area problem.
Okay.
I got to think for a second, though. from there to there, from here to here, and this square hot tub we'll say is 2x and x. Let me go back and make that 12x minus 1 instead of 2x minus 1. Because otherwise the picture doesn't make much sense. Okay? In other words, I couldn't leave that at 2x minus 1 and have this be 2x.
Right.
So, what is the area of the shaded region?
Okay, so you have to take 12x minus 1, right, times 3x plus 4, and we have to find half of that. So we take a equals half, right? Okay, so we're going to distribute the half to the 12x.
Hold on. That's the area of the full triangle, right?
Right.
Okay, the shaded area has to have what subtracted from it?
Oh, the 2x times x, which is 2x squared.
So there's your shaded area. Now we just have to simplify. Okay?
Okay.
Multiply those. The way to simplify this is to multiply those first.
Okay. Okay, so let's see. 24, 38.
36.
Oh, 36, okay, sorry. And then x squared.
Okay?
And then it would be 12 times 4. This would be 48x. And then we're going to do negative 3x. And then it's going to be a negative 4. Minus 4.
Okay? And all of that divided by 2 minus 2x squared. Okay?
So we would divide first, right?
Yeah, I didn't really mean to have fractional numbers here. Let's see. Let's make that a 4x right there.
Okay.
So this becomes a 4x right here.
Okay.
Now, what's the next step?
Divide by 2.
Divide by 2, so what's the next line?
Okay. So it'd be 6x.
36 divided by 2.
Oh, it's 18. I'm bad. I'm so sorry.
That's all right.
And then 48 divided by 2 is going to be 24. And then 2 minus 2x, and then minus 2.
Okay, and then minus the 2x squared. Now let's simplify all of that. We got 18x squared. How many x's? Ah, we got 16x.
So, be 16.
Takes care of that one and that one. Okay.
Okay, then it'll be plus 24, or sorry, 22x, and then minus 2.
Okay. Let's do something with the last 4 minutes.
Okay.
Hold on. As long as it doesn't take me 3 minutes to pull it up. Come on, I can't find it. Here it is. If you practice these, only check those boxes.
Okay.
You don't need to practice 2 by 1s, 2 digits by 1 digit. You don't need to know those. But you definitely need to know the 1 by 1s. Okay? So, Just give me the answer, I'll put it in, and I want you to go as fast as you can go.
Okay. 1. Okay, negative 11 divided by negative 132.
It's actually negative 132 divided by negative 11. When you state that, you got to state it that way.
Okay. Let's see. 11 times 11 is...
I wouldn't expect you to know this. This is 12. Is it plus or minus?
Oh, okay. Plus.
Okay. And I don't even think you need to know that. I don't care about that. You don't need to know 11 times 12 is 132. But you do need to know stuff like this. And you need to know stuff like this quickly.
Okay. 6.
7.
Or so... negative 10 times 5, that's negative 50. 6 plus negative 5, which is just like subtraction. So, 1. 12 by 12 is 1. Negative 6. It's going to be negative 9. Divided by 27, isn't that 8? No. 9, okay.
Remember that the nines tables, any number multiplied by 9 adds to 9.
So like 2 plus 7 is 9.
2 plus 7 adds to 9. That means that has to be divisible by 9, which means 9 has to be the answer.
Okay.
Okay?
Okay, negative 6 plus 1, that's negative 5. 7 divided by 14, that is negative 2. Negative 6 plus negative 7, or, okay, sorry. That's going to be negative 13, right?
Now, what I'm going to say that you're a lot better at this than you are at doing this when we're solving problems.
So, yeah.
I'm not sure why.
Okay. It's going to be a negative 13.
You're pretty good at this. You don't make very many mistakes. I notice you do make some mistakes on your multiplication and division. And if you want to, I mean, you're working hard. Don't get me wrong. You're putting in a lot of work. You're doing 2 hours a week. But if you want to improve your math the most, spend 5 minutes a night on this. That's it. 5 minutes a night. Going through it as fast as you can. You'll see where you make your mistakes. After a week of that, you won't be making any more mistakes.
Okay.
Okay? It's called aplusmath.com.
Okay.
I think I've sent you a link to it before. But it really would be worthwhile to you because you understand most of the math we're doing. The only thing is that every now and then you make a mistake in multiplication or division.
Okay.
And this would totally take care of that. And this is the only way I know to take care of that. You definitely do not want to get used to relying on a calculator to do these kind of processes. You don't want to ever have to rely on a calculator to multiply 5 times 8. It just will slow you down so much. And it might make anything harder than algebra impossible even. So that you'd be good at math, and I mean really good, if you were good at these.
Okay.
And you can get good at these pretty easily. It wouldn't take much time at all.
Okay.
All right, Connor. I will talk to you next time.
Okay, thank you so much.